let's go ahead and use SOHCAHTOA, that right triangle trig ratios, to solve for the missing side. Now we can do this just given the measure of an angle and the measure of a side. That's what's really cool about this. So our reference angle on the first one is 40 degrees. Now I realize this only works for right triangles. We have to do what's called law of sines and cosines if you don't have a right triangle, and we'll take a look at that in the next unit. So what do we need to find? We need to find our opposite side, and we have our hypotenuse. So if you were to look at SOHCAHTOA, so what we have is we have the opposite. So it could be sine or cosine, or sine or tangent right now. I think cosine is out. And then we have our hypotenuse. So now tangent's out. So we're looking at sine. That's my recommendation. Label your sides and then look at SOHCAHTOA and realize which trig function you need to use. So sine of 40 is going to be the opposite, which is unknown. I'll put an x over 7. Now what you have to realize is there's two different situations we're going to run into. And so I want to talk about that right now. And there's actually 3 total. We're going to talk about case 1 and case 2 of solving for x. So if you end up with sine of, let's just say 20 equals x over 5, you're just going to multiply the 5 to the other side and get x equals 5 times sine of 20. I'm going to put parentheses around the 20. I forgot that that's the input. You can't multiply the 5 times the 20 because the 20 is inside the sine function. It would take some identities and things in order to be able to put that 5 inside of there, and it won't be a 5 that's just going to multiply in there. So just simply put the 5 in front. Use a calculator at that point. The other situation you might run into is where x ends up on the bottom. So notice here x is on the top, here x is on the bottom. Now if you do the whole, basically you put this over 1, cross multiply, solve for x, what's going to happen is you're going to end up with the final result is 5 over sine of 20. So notice here we take 5 and multiply it by the trig function. Over here we take 5 and divide it by the trig function if x was on the bottom. So that's what we do if you end up in that situation. So that'll be case 2. And case 3 is what happens if x ends up inside and we'll talk about that in the next section. Okay, so x is on the top, so we just multiply it. So x equals 7 times sine of 40. Make sure you're in degrees, because this is degrees, right? Radians we'll use later. I know we used radians earlier this year. Let's take a look. So we're going to have 7. I needed to put 7 first. I don't know what I'm doing here. Sine of 40. And that got me 4.4995. And we want to round to the nearest hundredth. So that's the second decimal place. So if you bump up the 9 to that, it just ends up bumping this to a 4.5 because that 9 bumps up the 4, and that'll be your answer. Let's look at another one. This one, okay, we end up with, I'm trying to see if we can end up one with the second case there. Seems like all of these ended up the easy one. I should write my own example. Let me change this one around. Let's just say this is x and this is 7. All right, so what we have is we have our opposite from the reference angle. That's a horrible arrow there. And we have our adjacent. So if you were to look at SOHCAHTOA, this follows right along with tangent. Opposite and adjacent, right? So tangent of 65 equals opposite over adjacent. Notice opposites first, so it gets put on top. Now since x is on the bottom, this is the case where we're going to divide. That's why I rewrote the problem a little bit. Just to show you guys an example where we have to divide. So then from there, 2, 6. And that's the main idea.